Welcome back to Space Repo, your portal to the cosmos. Today, we journey back in time, not just a few thousand years, but billions. We're going to witness the most violent event in our planet's history, a cataclysm of unimaginable scale that forged the world we know today and gave us our constant celestial companion. Let's rewind the clock to 4.5 billion years ago. The solar system was a chaotic and treacherous place, a cosmic demolition derby of newly formed planets and rogue celestial bodies. Our own Earth was in its infancy, a molten sphere of rock and metal, barely recognizable as the blue marble we cherish. It was during this turbulent era that Earth had a fateful encounter. A protoplanet, a world in its own right, was on a collision course with our home. Astronomers have given this long-lost world a name, Theia. Theia was no mere asteroid. It was a planetary titan, roughly the size of modern-day Mars, hurtling through the dark void of space. Its orbit was unstable, and destiny had placed it on an intercept path with the young, primordial Earth. The moments leading up to the impact would have been a terrifying spectacle. An observer on Earth, if one could have survived the searing heat of the planet's surface, would have seen a new star grow in the sky, brighter than any other. This star would have rapidly expanded, resolving into a giant, approaching sphere. Theia, a world unto itself, filling the entire horizon. The gravitational forces between the two planets would have begun to wreak havoc, distorting their shapes, pulling them inexorably towards each other. Then came the impact. A moment of silent, cosmic violence that defies all human comprehension. Theia, traveling at tens of thousands of kilometers per hour, slammed into Earth not head-on, but at a glancing angle. The energy released in this single instant was staggering, billions of times more powerful than all the nuclear weapons on Earth combined. The collision was so immense that it didn't just create a crater, it fundamentally reshaped both celestial bodies. Theia was utterly obliterated. Its core and mantle were vaporized and shattered, mingling with a significant portion of Earth's own crust and mantle. The impact was so powerful that it liquefied a vast portion of our planet's surface, turning it into a seething, global ocean of magma. Imagine our world, not with oceans of water, but with oceans of molten rock, glowing with incandescent fury. Temperatures on the surface would have soared to thousands of degrees Celsius, hot enough to vaporize solid rock instantly. A colossal plume of superheated vapor, gas, and molten debris was ejected into space, a fiery arm reaching out from the wounded Earth. This wasn't just a splash, it was a planetary-scale eruption, a cloud of material containing the remnants of both Theia and our own world. This massive debris cloud didn't escape Earth's gravity entirely. Instead, it was captured in orbit, forming a dense, searingly hot ring around our planet. Earth, for a time, would have resembled Saturn, but with a ring made not of ice, but of fire and molten rock. Within this chaotic ring, gravity began its slow, patient work. Particles of dust and rock began to clump together. Small accretions grew into larger ones, sweeping up more material as they orbited the wounded Earth. Over time, perhaps in a period as short as a few hundred years, a dominant body began to form within the ring. This growing sphere, this nascent world, pulled in more and more of the surrounding debris, clearing its orbital path. This new body, born from the violent union of Earth and Theia, was the Moon. In its infancy, the Moon was a ball of molten magma, glowing a dull red in Earth's sky, and it was much, much closer to us than it is today. If you could stand on the primordial Earth at that time, the newly formed Moon would have appeared as a monstrous, colossal sphere hanging in the sky. It would have dominated the view, appearing perhaps 10 to 20 times larger than the Moon we see today. The proximity of this massive new satellite had profound effects on Earth. The gravitational pull between the two bodies was immense. The Moon's gravity tugged on Earth's molten surface, creating colossal tides not of water, but of magma, that swept across the planet. Likewise, Earth's gravity locked the Moon into a synchronous rotation. This is why, even today, we only ever see one face of the Moon. It was tidally locked from its very birth. The formation of the Moon was not just a spectacular event, it was arguably the single most important event for the future of life on Earth. Before the impact, Earth's rotation was much faster. A day may have lasted only about 6 hours. The planet also wobbled violently on its axis, leading to extreme and unpredictable climate shifts. This instability would have made it incredibly difficult for complex life to gain a foothold. But the Moon, our new celestial partner, changed everything. Its gravitational pull acted like a brake, gradually slowing Earth's frantic rotation over billions of years, lengthening our day to the familiar 24 hours. More importantly, the moon's gravity stabilized Earth's axial tilt. It acts as a giant anchor, preventing our planet from tumbling chaotically. This gave Earth a stable, predictable climate with regular seasons, a crucial ingredient for the evolution of life. Without the moon, Earth might still be a frenetic, wobbling world with a short day and wildly fluctuating temperatures. The stable environment that allowed life to flourish and evolve into complex forms might never have existed. The evidence for this giant impact hypothesis is compelling. When the Apollo astronauts brought back rock samples from the moon, scientists made a startling discovery. The lunar rocks were remarkably similar in composition to the rocks of Earth's mantle. They shared the same isotopic signatures, a kind of geological fingerprint, which strongly suggested they came from the same source material. Yet, the moon is significantly less dense than Earth and has a much smaller iron core. The Theia impact model elegantly explains these observations. The collision would have primarily ejected material from the lighter crust and mantle of both Earth and Theia, while the dense iron core of Theia merged with Earth's core. This explains why the moon has a composition similar to Earth's mantle but lacks a large, dense core of its own. So, the next time you gaze up at the moon, that serene and silent orb in the night sky, remember its violent and fiery birth. It's not just a rock floating in space, it's a piece of our own planet, a twin born from a cosmic catastrophe. The moon is a constant reminder of the chaos of our solar system's past and the incredible series of events that had to occur for our world to become a habitable oasis. It is the stabilizer of our climate, the giver of our tides, and the silent guardian that has watched over the unfolding story of life on Earth for billions of years. The Theia impact wasn't an act of destruction, but an act of creation. It was the violent forging that gave us our world, our stable climate, and our celestial companion. We are, in a very real sense, children of this ancient, cataclysmic collision. Thank you for joining us on this incredible journey back to the dawn of our world. If you found this cosmic story as fascinating as we did, be sure to subscribe to Space Repo for more explorations into the wonders of our universe.